This problem asks us to consider the differential equation dy dx equals y squared over x minus 1. And the first part is to perform the slope field. On the axis provided, sketch the slope field for the 6 points indicated. So remember to find what happens with a slope field. We replace the coordinates of the point into the differential equation and simply calculate what the slope has to be. So for example, at 0, 0, if we do 0 divided by negative 1, we get 0. So at that point, the slope will be 0. At the point 1, 0, comma 1, that would mean that we would have a 1 in the numerator and a 0 minus 1, or a negative 1 in the denominator, and 1 divided by negative 1 is negative 1. So there is our slope of negative 1. At 0, comma 2, 2 squared is 4. 0 minus 1 is negative 1. 4 over negative 1 is negative 4. So the slope here would be negative 4. Moving on, we'll skip the 1s because that is undefined in the denominator. It's going to cause 0 in the denominator. So when we go to instead 2 comma 0, we now have a y coordinate of 0. So the bottom being 1 means we'll have a slope m equals 0. At 2 comma 1, in the top we'll have 1 squared. In the bottom we'll have 2 minus 1, which is 1. So we're going to get a slope of 1. And then finally, for 2 comma 2, we'll get a 4 over a 1, which is a slope of 4. So that would be an m equals 4. So that's how you perform the slope field command. Okay, next part is asking us to let y equals f of x be the particular solution to the given differential equation with an initial condition. Write an equation for the line tangent to y equals f of x at x equals 2, and use that to approximate f prime of 2. Okay, no sweat. In order to find the tangent line approximation, we need a point and a slope, and we were given the point 2 comma 3. So for part B, we know the point is 2 comma 3, and with regards to the slope, dy dx was y squared over x minus 1. So if we evaluate that at 2 comma 3, we're going to get 3 squared, which is 9, over 2 minus 1, which is 1, which is a slope of 9. So therefore, the equation of the tangent line would be y minus 3 equals 9 times x minus 2. This is the equation of the line tangent, and so if we wish to use this to approximate what f of 2.1 is, we could say that f of 2.1 is approximately equal to, let's say move the 3 over, 3 plus 9 times 2.1 minus 2, which is 3 plus 0.9, in other words, 3.9. So our approximation would be 3.9. Okay, finally, this problem asks us to actually find the particular solution with 2 comma 3. So yet again, we'll start off with the beginning differential equation. So part C is going to start with dy dx equals y squared over x minus 1. And then we are going to separate our variables and write this as, let's see, dy over y squared equals dx over x minus 1. So now when we try to perform an integral to both sides, the integral of y squared would be, let's see, y to the negative 2, add 1 to the exponent, and divide by the new exponent would be negative 1 over y. And then for the antiderivative of dx over x minus 1, we get a logarithm of x minus 1, of course, plus some kind of constant. Now, using the initial condition of 2 comma 3, that means that negative 1/3 would be equal to ln of 2 minus 1 plus c. ln of 2 minus 1, that would be ln of 1 plus c, and of course the logarithm of 1 is 0, so this just becomes c. So the c is equal to negative 1/3. So now we're figuring out that negative 1 over y must be equal to ln of x minus 1 minus 1/3. Now the problem does ask us to figure out y equals f of x, so we should probably go solve for y equals f of x also. So let's multiply through by negative 1, so that 1 over y equals opposite logarithm x minus 1 plus 1/3, and then we'll just take a reciprocal. So y equals 1 over negative ln x minus 1 plus 1/3. And that should be sufficient for the problem.